Okay, class. Tonight we're talking about section 1.2, linear equations and rational expressions. If you recall from the last class, we dealt primarily with linear equations in that when we had a problem similar to x minus 5 is equal to 0, and what we wanted to do was find the value of x. Well, the way we did that was we added 5 to both sides. By adding 5 to both sides, that allowed us to cancel out this 5 here, and now we have x is equal to 5. So that's how we will solve this problem right here. And we could also check it. The only thing we had to do to check this, now that we know that x equals 5, we plug it right back into there and say 5, because it told us that x is equal to 5, minus 5 is equal to 0. So we know that this checks out as being correct. So that's how we did things in the last section prior to going into test number 2. Now, as we go into test number 2, we're taking it a little step further in that we're dealing with equations such as 16x plus 2 is equal to 13x minus 7. So if you look at this linear equation here, you have 16x plus 2 on one side of the equal sign and 13x minus 7 on the other side of the equal sign. The way we would approach this here is that first, let's go ahead and draw a line there and bring our equal sign down. Now, we want to cancel out the 16x, the 2, or the 13x, and the 7. In order to do that, whatever we do on one side, we also must do on the other. So let's start with 2 first. In order to cancel this 2 out, this has to be a negative 2. If it's a negative 2 here, well, it has to be a negative 2 here as well. Then this cancels out. So now we have 16x is equal to 13x minus 9. Why is this minus 9? Because we have a minus 7 and a minus 2. Minus 7 and minus 2, we add both of those together and it takes on the sign that's common to both of them, which is minus. That's why we have minus 9. Now, we take the 13x and bring it on this side. We can't take the 16x and bring it over here because then that will leave this as 0. So, bring the 13x over here, except it's negative 13x, because that's the only way we're going to get rid of this 13x. And the goal is to get the x's on one side and the real numbers on the other side. So this will be minus 13x here. This is minus 13x here. Now that we have that, this is going to cancel out because 13x minus 13x is 0. We bring the minus 9 down. Then we have 16x minus 13x. That's 3x. We're still not finished because we need to get the x over here by itself and the real number over here by itself. So we just divide by 3 on both sides. And our answer is x is equal to minus 3. That is the answer. And that's the answer of a negative 3 because a negative divided by a positive is a negative. So that's negative 3 there. Okay, so I hope you understood that. We're going to do some more. Let me erase this first. So continuing on, if we have 1 over x, well, give me some more board space. So I'm going to erase the title too because I've already said we're in section 1.2. So if I say 1 over x equals 1 over 5 plus 3 over 2x. First thing to notice here is that the denominators in each one of these are different. So we just can't add straight across. But if we find the least common denominators, that allows us to get rid of these denominators. Then we're just dealing with a linear equation. Because right now, the way that it's written, it's a rational equation. So what is the LCD of this? We have x, 5, and 2x as our denominators here. Well, the LCD is 10x. So let's multiply everything by 10x. So right here, we have 10x multiplied by 1 over x is equal to 10x multiplied by 1 over 5 plus 10x multiplied by 3 over 2x. Now that we have that, we're going to cancel some things out. We're going to cancel this out and cancel that out. Now we just have 10. Remember, I said the goal was to get rid of these denominators. Now we're able to do that. So it's 10 equal to, okay, 10 divided by 5 is 2. So this will be 2x plus 10 divided by 2 is 5. The x is going to cancel each other out. 5 times 3, that's 15. So now we'll have 15 right there. Okay, we're almost there. Because, as we said before, we want to get our real numbers on one side of the equal sign and our x's on the other side. So now, let's subtract 15 from here and subtract 15 from here as well. Continue bringing our equal sign down. Now, what we have here, 10 minus 15, that's a minus 5, is equal, because this canceled out, 2x. Once again, we have not gotten our x's on one side and real numbers on the other side. The only way we can do that here is to divide by 2 on both sides. Once we divide by 2, this cancels out. X is equal to negative 5 over 2. And this is our answer there. All right. So I hope you'll follow me as I go through these problems. Have a couple more to go to as well. So let's continue on. And the good thing about video is that if I'm going too fast or going too slow, you can always replay it over and over and over again until you get it. So now, let's do another one. This one right here says 6 over 3x plus 2 is equal to 2 over x minus 1. Here, our LCD is 3x plus 2 and x minus 1. Now that we know what our LCD is, we multiply everything by it. Okay, so we have 3x plus 2, x minus 1 multiplied by 6, 3x plus 2 equal 3x plus 2, x minus 1 multiplied by 2, x minus 1. So the first thing we know here is that we can cancel some things out. So let's go ahead and cancel this out and this out. Then x minus 1 out here, x minus 1 there. So then we have 6 x minus 1 is equal to 2, 3x plus 2. Then we can distribute this 6 throughout this parenthesis here. You recall how we did that last class. As well, we're going to distribute this 2 throughout the parentheses there. Now, once we do that, what we will have is 6x minus 6 is equal to 6x plus 4. Then from there, let's subtract 6x from both sides. This cancels out. 6x minus 6x is 0. 6x minus 6x is 0. So, minus 6 is equal to 4. Well, we cannot get the x's on one side here. Now we just have two real numbers in the center. They're equal to each other. Where? Well, the answer here is no solution or inconsistent. I'm not sure which term the book uses, but either one of those terms is correct because we know that we do not have an answer. So this really cannot be solved. So that would be the answer, no solution or inconsistent. Now, it's important to remember that for your homework or even a test, sometimes this is given as an option for the answer. Do not always select that as being the answer because sometimes it's not. And I will bet that 99% of the times there is a solution to the problems that you're given. But just be aware that if you cannot solve it, it's always a possibility that the answer will be no solution or inconsistent. Okay, let's do another one. This one is x minus 1 over 3 minus x plus 4 over 5 is equal to 3. For this one, the LCD is 15. So now let's multiply everything by 15. So it's 15 multiplied by x minus 1 over 3 minus 15 multiplied by x plus 4 over 5 equals 15 multiplied by 3. Here, what we have is 5 over x minus 1 minus 3 over x plus 4 is equal to 45. Great. Now we've gotten rid of the fractions. We're just dealing with a straight linear equation now. No fraction at all. So this should be fairly simple, being that we would distribute this 5 throughout and distribute that 3 throughout there. Once we do that, then we have 5x minus 5 minus 3x minus 12 equals 45. So instead of moving things over to one side and moving things over to the next, first let's figure out what do we have that have like terms on this side of the equal sign. Well, we have 5x here, 3x here, and then we have 5 and we have 12. So let's deal with those things first before we move anything from one side to the next. And we know that 5x minus 3x, that's 2x. So we have 2x. Then we have minus 5 minus 12, that's minus 17, is equal to 45. Okay, so should we move the 2x to this side? No, we definitely don't want to do that because we do not have an x over here. But we can say plus 17 here, plus 17 here. This is going to cancel out, so then we have 2x is equal to 62. Divide both sides by 2. This cancels out. X is equal to 31. And that is our final answer for this problem right here, 31. Okay, we're going to tackle one a tad bit more complex, or maybe not complex to some of you, but more steps. Let's just say it like that, more steps. So, if we have this problem right here, minus 1 over x plus 1 is equal to 1 over 3x plus 3 minus 2 over x minus 4. Take this problem here and we find out LCD. First, I'd like to say, is there anything here that we can factor? And we know that we can factor 3x plus 3. So we have our denominators, x plus 1. We have 3x plus 3. And we have x minus 4. Well, for this 3x plus 3, this can also be factored out to be 3x plus 1. So our new denominators are x plus 1, we got it up there, 3x plus 1, then x minus 4. Okay, now that we have that, we know that our LCD here will be 3x plus 1, x minus 4. Now that we know that, let's come over here and let's multiply everything by our LCD. 3x plus 1, x minus 4, multiplied by minus 1, x plus 1, equals 3, x plus 1, x minus 4, multiplied by 1 over 3, x plus 1, minus 3, x plus 1, x minus 4, multiplied by 2, x minus 4. Okay, so the LCD is the only thing here that's very long. Everything else should be straightforward. So let's go ahead and cancel out some things to get rid of this denominator. So we cancel this out, cancel that out. 3x plus 1 there, 3x plus 1 there, x minus 4 here, x minus 4 there. Once we do all the cancellation, then what we're left with is minus 3x, right? Because it's 3, x plus 4 minus 1. So let's just say minus 3, and I'm going to say x minus 4 equal, since this cancels out and that's canceled out, x minus 4. Now we have minus 3 times 2. Then we have x plus 1. All right. So now let's get rid of the parentheses here. So this is minus 3x plus 12 is equal to x minus 4 minus 6, because this minus 3 and 2 is minus 6. Then I'm saying that plus that right, we'll multiply by that right there, minus 6x minus 6. Now that we have that, let's add our like terms over here. We don't have any like terms on this side. So let's just bring this down. 3x plus 12. Our like terms will be x minus 6x. That is what? Minus 5x. Minus 5x. Now we have minus 4 minus 6. It's minus 10. Exactly. So now let's add 10 to both sides. If we add 10 here, add 10 there, this is going to cancel out. Now we have minus 3x plus 22 is equals to minus 5x. Okay, now let's add 3x to this side. Add 3x to this side. Got my equal sign here. Just bring it down just to be consistent, because consistency is very important in math when you're doing these problems like this, because there's so many steps and you don't want to forget anything that could potentially throw you off. So let's knock that out. Then we have 22 is equal to minus 2x. Divide by minus 2 on both sides. Let's bring it over here. I found our answer because these are going to cancel out. X is equal to negative 11. All right. That one was pretty long, but it's a very good example. It really uses everything that we learned in the other little examples. So everything built upon itself. So once again, this is section 1.2, linear equations and rational expressions. And that is the end.